going on. This is the Inventor IO Hero, which is compatible with the Arduino Uno, and there's not much going on it right now. It's got a few connections, and mainly all it has going on at this point, as you can see, it's got right here power and ground. That's 3.3 volts and ground. And then there's a little yellow and green over here, and they are, green is SCL, and the yellow is SDA. So that's a two-wire, as they call it, or in this case, I2C connection. So all four of these are being used. Boy, this is a mess. All four of these are being used to hook up just a few of these pieces along the way. As you can see, 1, 2, 3. That's 3 of the MPR 121s, which, wait, hold on one second. Okay, so using the Arduino-compatible board to hook up 3 of these kinds of things. This is the MPR 121 touch sensor chip. This is one that I had used on something else. And the way it works is those 4 wires I just talked about hook into 4 of these pins, and on the other side you have a dozen touch sensors. So the idea is you power it and give it that that I2C connection over here, and then you use code to tell it what to do when people touch different pins. So what you can do with this is, of course, instead of pins, you could run a wire to something, so that when people touch the something, it's like it activates the signal. They're pretty cool. I love these devices. And how do you use 3 of these with only 4 wires? Well, there's lots of good documentation about this that I'll share a link to. But the short version, if you can ignore this stuff up here for a moment, this stuff up here is something else going on, which I'll talk about in another video. Pretend that's not there. The red and black, which are the 3.3 volts and ground, they connect in here, and then I just have another wire that in series comes down and connects to this one, ding ding, and then down to this one, same. So they all can get enough power from that single pair of power connectors. The same thing is true for the I2C connection, the green and the yellow. They're coming down, they connect to the appropriate pins here, and here, and here. So each of these is connected to the same 4 little pins or ports on the Arduino, as we'll say, on the Hero, and it's enough. It's like 99% enough. The only question that comes up next is, how does the Arduino know the difference between these 12 sensors and these 12 and these 12? And the answer to that, thanks to the documentation, you have to do something to a couple of these to differentiate them from in the mind of the microcontroller. So let me show you. So here's the first one. So the first of the 3 is actually down here on the end, and I've written on it. Now this is just hooked up in the regular way. All I've written on it is 0x5A, and that's the kind of the default hardware address of this device when hooked up to a microcontroller. And so what you can do is you can say, well, let's call this one the first one, and let's call this one the second one. As you can see, this one is called, I've written on it 0. I wrote on these just for myself so that I can remember what's happening. 0x5b. But some different things I had to do to the wiring in the back of this little device so that the microcontroller knows it's another distinct, separate set of 12 electrodes. And then, of course, the same thing happens here. You have to do something different still to this one. There's basically different ways to hook up the an address pin, which I'll show you. And so this is 0x5c. So now what the microcontroller knows, quote unquote, is that yes, there's some stuff, some powered stuff that can communicate on these two lines, and it's not just one of something, it's three of something. That's kind of a dumb way to explain it, but that's it's one of the reasons I love this little device, is because there's really a minimum of wires required to get 36 separate buttons, and that's what we want. I want to be able to press a key and have it be recognized over here in the microcontroller as just a key, so that I can, in the code, I can say, oh, that's a C sharp, middle C, or whatever, I don't know. So that's part of this mess, is a microcontroller talking to three little devices. And the rest of it we can talk about in another section of this video. As you can see in my kind of gross and clumsy way, alright, so we have the 3.3 volts comes into this board, but then I continue a line down which is going to help it power the next board. The same thing is true of ground. There's where it comes in, there's where it comes out. As you can see, that's my pattern. There's where the I squared C green and yellow lines. In order for this to be distinguished from the other two, for this particular one, I had to make a jump. Let's move this wire just a little. I had to make a jump between this address pin, which I otherwise wasn't going to need to use at all, and this SDA pin. There's just a little secret code built into these things such that if those two wires are connected, it is recognized with this address by the microcontroller. Now that's useful when you have more than one of this exact same kind of I squared C device on the same I squared C bus. So we move down. Never mind that for a moment, that's something else. Here's the second MPR 121 board. And as you can see here, here's the power coming in again and going out again. Same thing with all these. Ground comes in and goes out again. SDA and SCL. They come into this board. They move along down the line. And for this one, we had to do a similar thing where we had to connect, again, the address pin to another pin to make it be a distinct instance of the MPR 121 sensor board. The very last one, let's follow the lines, boom, 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 here's the last one. The last one actually is the one that's using the default hardware address for the device, and this one has the simplest connections. It's just those four wires coming to their appropriate pins on here. So that altogether gives us our 36 pins. So for the sake of consistency, you can see that I've also written those addresses on a piece of tape, each in little sections as we go down, just so I don't forget that, for example, the 12 notes that these will trigger are these 12 notes. Boom, 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 the first octave. Same here, there's 5B, the second octave, and there's my third octave. And this poor little guy over here doesn't have a job to do yet, but we can figure out something for that 37th note at a later point. So in the future, we'll talk about what is all of this. What does it intend to be? That'll be another video soon. How does it all go together? Why have I added a MIDI port? What are all these things for? And how are we going to get these keys? Right now, if you notice, there's nothing. It's just plastic and plastic. So how are we going to get each of these NPR 121s to recognize that a button has been pressed? So usually when you take these keyboards apart, you find like the cheapest ever action under here. It's a strip of PCB, but it's a pre-made to the device itself kind of circuit that you could repurpose by dealing with like a scan matrix. I've done that a couple times and I don't prefer it. I prefer the gross gluey wires everywhere, and each note gets its own sensor. That's what I'm shooting for in this device. So right now the circuit doesn't really make any sound because I haven't yet told this device how to make sound, but we're going to do that as well coming up. All right, well, that is kind of where we're at with the sensors for generating notes.